Today we're talking with Bryce, and I already had conversation before with him, and it was extremely interesting because it's about the world that I do not fully comprehend. It's kind of advanced and closed at the same time, right? So
Indeed.
let's start from the beginning. Bryce, introduce yourself. Who are you?
Thank you. So my name is Bryce Mitchell. I'm Vice President of Core Network Engineering at a Canadian telecommunications company called Rogers. I guess I've been working in the telecommunications space for a little over 20 years now. Started out when cell phones were new and just a thing, and text messaging was something that was new and novel, and then look where we are now. Couldn't even do mobile data back in the day, if you can imagine such a time. A lot of things have changed since then. Done a lot of work in startups as well too, looking after software development in the cloud space. So I have a bit of a unique background, I should say. So that's a little bit about me.
When we started the conversation before this session, right? I think that I had a comment like, hey, why don't you just run your class, everything in Kubernetes and put it on AWS? And you started rolling your eyes, kind of like, it wouldn't work.
Only for that easy.
Yeah. And usually when people tell me, oh, that wouldn't work, my first association is, oh, yeah, because we have some silly internal policies. It's not that it wouldn't work, but we cannot convince our management to do it, right? But in your case, it's a completely different story, right?
Yeah, we actually have some real engineering challenges that make it a little bit difficult for us to adopt that technology at scale. So maybe I should do just a tiny bit of background on telecommunications and kind of how that world works. And I think as I go through that, it'll probably give everyone, yourself included, a bit of a better perspective on why there are some engineering challenges in the telecommunications space, and why it's not as simple as just adopting containers or moving to a cloud-native architecture and life is good. Even though those aren't trivial things, I don't mean to downplay them, but sadly we have even greater challenges than that. And I think one thing that a lot of folks maybe don't realize from the outside looking in is that the telecommunications industry is a bit of a different beast. We don't typically, from an engineering perspective anyways, develop a lot of software historically. A lot of what telecommunications have been in the past has been purchasing very purpose-built hardware and software platforms to deliver a function in a network. If I just use a very simple example, the packet core, the thing that does mobile data, typically that's been a box that you've bought from a vendor. So it's been a very purpose-built machine that is designed from the ground up, that software, hardware, and everything in between, to deliver a specific function in the network. And if you actually think about what a telecommunications network is, whether it's internet in your home or mobile internet or even mobile phone calls and text messagings, it's really a collection of these functions, these physical boxes, if you will, that when you connect them together in a way that's very well laid out by the standards communities, that comes together to give you the experience that you would call, home internet or mobile internet or your mobile service at the end of the day. And this was done on purpose. We had very demanding requirements from an engineering perspective in terms of reliability, in terms of performance and quality of service and things like that kind of led us to go down that path. But that being said, the evolution of cloud computing, virtualization, containers, infrastructure as a service, platform as a service, all those things, they have intrinsic value. And so the telecommunications industry has been very keen and looking at these technologies as well too, and trying to look at them from the perspective of how do we adapt these to our needs in our world. I think the other thing that's of interest as well too is kind of 2 points in there. One, telecommunications operators tend to buy these pieces of equipment. So rather than everyone developing their own thing, there's kind of like a global industry complex, if you will, of software developers, hardware developers, handset manufacturers, operators, and all of us come together to solve this global problem of delivering communications to our customers. So it's a bit more of a, it's probably more likened to the military-industrial complex than it is to traditional software development. There's this whole ecosystem that has to come together, and you can imagine there's no way one company could develop an iPhone and all of the core network engineering and everything else to make that happen. And then the second thing that's kind of unique to our industry as well, too, are standards, right? We have to have a very, very specific set of standards so that things work together. If I took my mobile phone from Canada to Europe and there were a different set of standards there, well, I wouldn't be able to get service. So how the phones interact with the network and how the networks interact with themselves are very, very, very tightly controlled and standardized so that all of this comes together in a way that makes the service work. So those are some of the unique challenges that we have in the way that we work in our environment. If that makes sense, if that kind of paints a bit of a historical picture, and then I can get into how containers and virtualization are a bit challenging in that space.
Yeah, but actually that does make a lot of sense. But now I'm becoming curious. If I have, I don't know, like 5 providers where I live, what makes one better than the other if almost everybody is running the same software?
Yeah, that's a really good question. In my mind, there's a couple things. One, there's a non-technical one, actually, I would say, comes down to how you treat your customers, to be honest with you. So if you don't have a massive technological differentiation between providers, it really does come down to customer service, price plans, things like that. So that is one of the ways that operators kind of differentiate themselves from each other, and one of the competitive factors that go into that. But there's also how you put the networks together that matters as well, too. I mean, you have to understand these are incredibly complex sets of systems at the end of the day. If I think about here, our situation in Canada, most of the major operators operate from coast to coast. I mean, Canada is half a continent. Let's not be shy here. It's a vast country, thousands and thousands of kilometers. And so how you set up your fiber optic networks, how you optimize them for traffic and latency, how you position your cell towers. You can imagine providing coverage from, say, a mobile perspective in Canada. Very difficult challenge, lots and lots of ground to cover. And some providers have, a better way of doing that, more optimized radio networks, better fiber right-of-ways, better configured equipment, better capacity management and engineering standards. So although the software and the hardware to a certain extent is somewhat standardized, just because of the scale and the nature of the beast, there tends to be a fair amount of differentiation between the carriers in terms of their technical capabilities. Another one to factor in is, say, spectrum, what airwaves you have. If we're thinking from a mobile perspective, those are something you have to have fairly deep pockets to acquire and fairly deep pockets to take advantage of. And so some mobile operators have invested more into that space and have more airwaves to use and better deployments of them, and they provide a better service at the end of the day. So those are some of the ways that carriers kind of differentiate themselves from their competitors in this space.
And so you mentioned the huge scale of Canada as an example,
yes.
Right? So yes. How does that work? How many? I mean, you don't have many data centers you have data centers that can cover the whole scale, right? I mean, when we're talking about public cloud.
That's correct. Yeah. So maybe this is a good moment to actually get into the topic du jour and talk about the cloud aspects of telecommunications and how we're evolving and everything else. So, interestingly enough, if you think about what I just talked about, a lot of what I'm talking about in terms of competitive differentiation between carriers it's an optimization problem, right? You're looking at capital money that you have. You're looking at the areas you need to cover, where your subscribers are and all that, and you're trying to optimize how you buy and configure that equipment so that you can do it in an economically efficient way and make money. We're all businesses at the end of the day. So that's one of the major reasons why the entire telecommunications industry, to be honest with you, started looking at cloud technologies. And this started, kind of follows the exact same trajectory and path that the public cloud world started with. Telecommunications started out with virtualization and infrastructure as a service, and then it has slowly moved on from there into containers and platforms and proper cloud management systems and everything else. But really, the big first driver that drove us down this path was efficiency and optimization. So in the world I described before, where you have all of these purpose-built machines and purpose-built sets of software delivering a piece of the network, if you will, you can imagine that at a certain point, you start to run into inefficiencies. You always have to buy hardware that's built to the peak because it's very difficult to add new hardware. At the end of the day, in a typical carrier, we usually have 12 to 18-month planning cycles, primarily because these are big, power-hungry pieces of equipment with lots of physical connectivity, lots of adjunct systems that have to work with them. It's a long planning cycle to get this stuff set up. And so when you have to plan for the peak, when you have to get everything engineered to make sure that you can run for quite a few months without adding any additional capacity, when you can't share or shift capacity between different functions of the network, you end up with a lot of stranded hardware and equipment and a lot of stranded capital at the end of the day. And that's not a good thing. That's a very inefficient way of doing things. And so that's an area where, that's one of the key drivers that drove us towards cloud technology and virtualization and everything else, which is to say, well, if the hardware is getting powerful enough that purpose-built machines are no longer absolutely necessary in order to be able to deliver the functions that we need, and if we start to look at some of the advantages of public cloud infrastructure and how and why they've been successful, we start to realize, hey, if we can have a shared hardware layer with some software on top of it that lets us easily move applications, network functions in this particular case, in and out of it, and we can scale them up and scale them down without having to necessarily buy new hardware all the time, which essentially is what the cloud started as, and that's kind of where we went down this path. Then we can be a lot more efficient. So I'll give a really simple example: picture messages. Lots of people like to send picture messages on their phone. Every year, without exception, we have a massive peak of picture messages coming out on a couple of days throughout the year. One of the more fun ones is Halloween. Every Halloween, we get like 10 times the number of picture messages because people are sending pictures of their kids and their this and that and the other thing. And so literally, if you roll back, say, 10, 15 years ago, well, when we first launched picture messaging, it was a disaster the first year. We just walked into a cliff. Messages got delayed for days. Everyone was upset. It was horrible. Executives were screaming. Life was not good. And then we decided, okay, we're not going to do that anymore. But we had to over-engineer. So we had to buy all of this extra hardware, all of this extra capacity. And most of the year, it just sits there consuming power, generating heat, and wasting money, all these extra licenses. And then one day a year, boom, for 12 hours, it gets busy. And we all sit nervously watching, hoping this year we don't go over the edge. Well, we don't have to do that anymore when we move to kind of a cloud environment, right? Because we can auto-scale those systems up and, even pre-auto-scale them, knowing that Halloween's coming every year, and then bring them back down again and use that generic hardware for something else. So that was kind of the precursor. That's why, telecommunications providers and the industry as a whole really started moving towards this space. Of course, there are other advantages as well too. As an industry, we want to make sure that we're acquiring the best and brightest talent. And as cloud becomes really popular, if you're not working in that space, it becomes very difficult to maintain your engineering pool and everything else. Lots of reasons for it, but the primary objective was really around efficiency and getting costs down. And you can imagine as well too. I mean, even though mobile and internet is part of our everyday life, and it's unthinkable when it even goes down, let alone to not have it, the growth curves are kind of stabilized, right? It's not like back at the early days of mobile where you're gathering millions of subscribers per year and everything else. Everyone who wants a phone's kind of got one. So when you get to an industry that's kind of plateaued in terms of growth, but you still need to continue to drive shareholder value because we are public companies at the end of the day, your next logical option is efficiency, right? You get your costs down. And so that's why these things have come in to bear. But there's challenges. And I have to say, adapting telecommunications engineering challenges to a cloud environment, it's tough. There's a couple big headwinds that we have kind of against us in this space that make it a bit more challenging with kind of the start of our conversation. So it hasn't been an easy rollout. Telecommunications providers are a few years delayed, I would say, from where the rest of the world is, because there were so many more things that we had to work through in order to make this technology really work for us and our purposes, if that makes sense.
Oh, yeah. I mean, and actually being a couple of years behind means that actually you're very much in front of most of the other industries in that case.
Yeah.
I mean, I worked with financial industries, so a couple of years behind. Right?
Yeah.
So that's kind of still precursors. What are you doing now? So kind of, or where are you going? Let's say, right? Are we already talking about Kubernetes? Are we talking about running on the edge? Something like that.
It's all coming. So I would say most network functions today that are deployed, they're mostly virtualized. So that's kind of the first step, and a lot of that's happened. That started in earnest about 3 or 4 years ago, and a lot of those things have happened. But we ran into challenges when we were doing that, and one of the things that we realized very early on is the hypervisor causes a lot of challenge. The abstraction layers, which is really what a hypervisor is, that you've put in order to be able to share computing and everything else, drives inefficiencies. And those inefficiencies, you might not really notice them if you're thinking of a website. I've done web development in the past, so I know those things didn't really impact us too much. A few milliseconds here and there, nobody really notices. It's all good. Your ability to auto scale and everything else just kind of really takes that right out of the picture in terms of a challenge. But from a telecommunications provider perspective, that's difficult. So if I think of something like, say, the internet, and so our mobile core networks, these are extremely high performance network functions, extremely high performance systems at the end of the day. These systems will support millions of customers sending traffic continuously throughout the day. And you really have to be efficient from a time perspective on how you deal with that internet traffic. If you add latency and delays to your customer's experience, it gets really frustrating really quickly. Especially when we're talking about, what we're doing today, real-time video conversations. A little bit of lag is really annoying. Same thing with voice conversations, online gaming, all of those things are very delay sensitive. And so we end up having to do a lot of work to make sure that the hypervisor, as much as possible, doesn't get in the way of that. And so if you think of it as a packet coming into a computer and the computer having to stop, run the hypervisor, figure out where to route that, send that into a particular OS, have it process it, and then undo the whole chain of events on the way out. It doesn't add much, but when you do it at this scale of traffic that we're dealing with, into the the terabit range and into the millions of subscribers and stuff like that, it adds up and it becomes a problem really quickly. So that was one of the early challenges that we had to deal with in cloud computing. And we had to deal with that in containers as well too. Containers brought very similar challenges into bear. So one of the challenges we had is we actually had to look at all of the the container network interfaces and plugins that go into a container and realize that the kind of the off-the-shelf ones, the things that everyone would be familiar with and maybe even not think about too much when deploying a container-based technology, really didn't apply in the telecommunications world. We had to put in much more efficient ones, ones that actually were a bit more aware of the hardware level and made sure that the network interface card in some cases could actually offload some of the processing to do it fast enough to be able to turn those packets around quickly enough. And secondarily, a lot of what we do, say, in network functions, is a really good example of this. If you think of a telecommunications provider, we NAT everything. So everything goes through a network address translation. So in containers, your address space, if you just take them out of the box, is always set to kind of one address space. Well, if I actually have to transform a packet continuously between two different network address spaces, I need two network interfaces for every container. There's just no other way to do it. So that was one of the things. There's technologies like Multis and things like that that were really pushed for and developed by the telecommunications industry so that we could bring that extra capability to containers so that it could actually deliver the capabilities that we needed and suited our needs. And I remember having these conversations very early days when we were meeting with the kind of luminaries in the container space and having them say, we don't understand, this works for everyone, why doesn't it work for you? And then going through all the whiteboarding and having folks go, oh, yeah, I have no idea how you would solve that with this technology. It's like, I know, that's why we're not using it just as of yet. So a lot of that has been worked through over the last couple of years, I would say. And now we're getting to a point where we really are starting to deploy containers at scale. The biggest one that's really pushed us into a containerized and cloud-native world has been 5G from a mobile perspective. Brand new technology, and everyone wanted to make sure that we did it right, we did it future-proof. And so, pretty much the whole industry is kind of rallied around a cloud-native, container-based way of delivering these services. And so you see that 5G is really pushing the envelope on that from a telecommunications perspective and really bringing containers to bear at scale for our industry. And so as you see, 5G start to proliferate out across the world, you're also seeing containers and platform as a service and all that other good stuff in cloud native really come into the engineering world and drive itself out, which is quite fascinating to see.
But is it, and I'm probably going to ask something very silly,
yeah.
Is it worth it, right? Kind of because you get, if I understood right, kind of you get, let's say, benefits of virtualizations and containers that are obvious to many people, yeah. But then you are kind of losing things that might not be of concern to many others, but kind of like that, kind of you gain some, you lose some, but I'm assuming that if you're going for virtualization containers, still the gain is higher than the loss, right?
The gain is higher than the loss. I would say that wasn't true the first few times we virtualized things. If you roll back a few years, I would say the loss actually exceeded the gains. We ended up in these kind of awkward situations where we had commercial off-the-shelf equipment, but the compromises we had to make in order for it to work in this environment kind of meant that you ended up having dedicated hardware to an application running a cloud stack. And then you kind of stopped and went, well, what did we just do? I think we just added some inefficiency, a whole other layer of software that drives cost and can fail and everything else. And we're kind of back to where we started again. It was a bit of an elephant in the room. for a while, and a lot of us in the engineering community just kind of kept pushing, going, well, yeah, this is kind of early days. We expected some problems. Please trust us. The benefit is coming. We just need to work through this, even though we've arguably made it slightly worse the first round than it got better. But I would say, yeah, like as the technology is maturing, we are really starting to see the benefits of these technologies come to bear. And you're starting to see the rest of the world or the rest of the telecommunications world anyways, kind of groundswell around it as well too. So even, I talk a lot about 5G, but even how we deliver, say, internet services over fiber or cable to your home, those things are all shifting towards cloud native type of solutions. So we are really getting to a point where we will be able to do a generic set of hardware in a site that can support multiple different things, and we'll be able to shift that capacity in and out and drive that efficiency. I really wish the pandemic had happened a couple of years from now, because one of the challenges we ran into, and I'm sure everyone in the world did, is suddenly overnight, everyone stopped using the mobile network and everyone started using their home network. And you could see the traffic graphs literally shift. Mobile went down, home internet usage went up, and then as things started to, and many countries have gone through this, they kind of unlocked a little bit and then they locked down again as the waves came. You saw the traffic kind of oscillate in and out. Mobile would pick up as we got a little bit freer, and then as the pandemic kind of perked up and the numbers got bad and we locked down and went home again, everything reversed. It would have been so nice to not have stranded capacity and to be able to shift that in between. We just weren't quite there yet. So we do see a lot of the benefits coming in this space. But I think, that one aside, these are kind of challenges, I would say, contained to our industry. If you're a telecommunications engineer, you would look at this and go, wow, this is super exciting. This is quite cool. If you're an average consumer, you might look at it and go, still kind of does the same thing. So I don't get it. This isn't all that exciting. I think for me, edge computing is, and you touched on it earlier, that's where it gets super exciting. So putting all of that aside, there's some very interesting things that are happening in this space. And so there's kind of two topics I want to chat about here. Before we get into edge computing, I just want to briefly touch on the public cloud, because it's all part and parcel of edge computing anyways. And you kind of asked earlier, and kind of alluded to it around the scale of Canada and everything else. And, a bit of a unique beast here, but other countries are in the same boat. I remember one of the conversations I had early on in this journey is just use the public cloud. Okay. And I said, we can't. And I got a very similar reaction that you got. Policy, this, that, just be open, think about it. I said, no. There's hard engineering challenges of why we can't. So if you look at Canada today, actually pretty much all of the public cloud providers are centered in kind of the central part of Canada, Ontario and Quebec, and they tend to be centered to the continent, centered to the country, same difference. And then you've got the rest of the country, which can be sometimes 3,000-4,000 kilometers away from those locations. And typically the hyperscalers of the world have addressed those markets out of near data centers and presence points that are in the US. So from a distance perspective, they're not bad. And in the software as a service companies that I've worked for and done software engineering for in the past, that was fine. It was absolutely fine. We had no data sovereignty concerns or anything of that nature. But if you look at it from a telecommunications perspective, it's just a non-starter to take all of our traffic and send it down to across the border to another country, like every single packet that everyone does, and then haul it back up again and connect it out to our subscribers. It's just it's just not a thing that's palatable. Hauling it across the entire country, also to keep it sovereign within the borders, also a bit of a non-starter. Unfortunately, when you get into thousands of kilometers, laws of physics and speed of light kind of matter. And when we talked about earlier, about latency and performance being an issue, that's a big issue. So if I were standing in Vancouver on a phone call, and all of that traffic had to go all the way back to Montreal, be processed, and sent all the way back out again to talk to my neighbor across the street, that wouldn't be acceptable. I mean, we would do that in a disaster scenario, absolutely, but we wouldn't do that as a regular engineering thing. So the public cloud really didn't work for us either. And most telecommunications providers are doing a lot of on-prem type of equipment deployments to get them close to our customers so that we can have the performance that we need. The other thing to keep in mind as well, too, is telecommunications providers are the internet, and the functions that we're talking about are the functions that create the internet and make it work. So it's a bit of a chicken and the egg to say, we'll just send it out to someone like a hyperscaler to process it. Well, how do I send it? The things that are doing the sending are the very functions that we're talking about. They need to be physically close to the customer in order to work. When I talk about the things that we're doing on 5G and stuff like that, like there's very much functions that they need to provide that are right at the customer. So unfortunately, a lot of that public cloud infrastructure just doesn't fit the need for what we have today. However, you do see that evolving over time. You do see more and more capacity coming on in closer locations. But I think what's even more interesting is the edge computing stuff. And so the hyperscalers have also run into the same challenge from the other direction down into the networks. And they're looking and saying, well, there's a lot of applications that we see that are coming that need ultra low latency, and it doesn't work for us and our customers to deploy in a centralized location and then have to go thousands of kilometers or even hundreds of kilometers to meet our customers. The latency gets too high. So self-driving cars is a good example. You don't want a self-driving car waiting milliseconds to get an answer back of whether it should avoid something. Earthquake detection was a really good one that I saw an example the other day where you really need edge computing. And so you start to see this kind of convergence, if you will, or lining up where the hyperscalers are also starting to reach out to the telecommunications industry and go, we need stuff close to customers. We have the software stack, we have the toolkits, we have the capabilities that developers need to create cool applications, but we have a challenge in that we need to get closer to the networks, the customers, the connectivity, if you will, at the end of the day, in order to get that latency down to deliver those services. And now, if you think of it from their perspective, it's a very difficult challenge to go out in the world and put 5, 6, 7 data centers in a country as vast as, say, Canada. It's a monumentally bigger challenge to, say, put several hundred of them or 500 or 600 of them, and then to scale that out across the globe and all the different countries and all of the different bylaws and all the stuff that goes with that. It just becomes a nightmare. And you really only get the true value and efficiency, the true low latency, if you're sitting nestled kind of really nice and tight and close into the network functions that are providing those services to the end user. And so what we're seeing now, and this is really cool, is we're seeing that edge computing start to drive out and line up with all the containerization, virtualization, and everything that we're doing in the telco space and come together so you can have this generic set of compute and cloud software infrastructure upon which you can deploy, we can deploy our network functions, and upon which third parties can deploy really cool and novel applications that they need to have that are super close to their customers. But the flip side is also true. Telecommunications providers, I don't think it would be a great idea if we all went out and did our own things and said, hey, if you want this edge computing application, you need to come to company A in Canada and do it their way. And then if you want to get at the rest of the country, you need to do it company B's way. And oh, by the way, if you go over the border, there's 5 different companies and they've all done it in 5 different ways. You really want that, at least in my mind, in order to make it successful, you really want that to be kind of global in nature. And that's where the hyperscalers come in. So it's this really cool kind of convergent symbiotic relationship where the things that drive a telco forward are moving into this technology. There's all these interesting and cool new applications that can benefit from it as well too. And together, we can kind of co-benefit on all this stuff. It's mind-blowing how this is all starting to come together. Truly exciting times to be in the industry. In the early days, if anyone had ever said, we're looking at mobile data and stuff like that, if all of this was happening, I would have said no. Like, there's just no way. There's no way. Once we've got a few 100 megabits per second to the phone, we're done. There's no other application you can possibly think of. And then all of this really interesting and cool stuff comes out of it, and it's just like, wow, we've got so much more to do. This is fascinating.
People usually don't even know how fascinating it is.
No,
until they start using it and experience an hour without it, right?
Yes.
I mean, the other day I read some studies that say that majority of people don't really care about 5G. As a person, kind of like, hey, I'm watching Netflix already. It's going fine.
Yeah.
I don't need 5G. But then we are talking about my car not working anymore in the near future if my connection is not fast enough, right?
Exactly.
So do I understand it right if I would interpret it as actually 5G is more enabler of other stuff than directly kind of like person to person?
Yeah, I mean, you hit the nail right on the head. If you look at 4G today, 300-400 megabits to a phone, if that goes up to a gigabit or higher, is that going to change my Netflix experience? Not in a material way. I mean, today, if you look at a 5G versus a 4G phone for that type of use case, you can't really tell. You might say, oh, it buffered a tiny little less to start up, but who cares? Where the real advantage is this whole plethora of new use cases that are coming down the pipe that 5G will enable. And it's really all about having that really high performance computing close enough to the mobile subscriber and with high enough bandwidth and low enough latency that you can do it in real time without having to do it on the mobile phone itself. And so if you're thinking, another really great example is things like augmented reality, which is starting to become a thing. If I envision a future world where, maybe the Google Glass thing finally takes off and I have something that gives me a bit of a heads up display, the only way for that to work without having terrible battery life is if most of the processing is done off to the side. And if I'm not, if I'm walking down the street and I've got an augmented reality view and it's showing me different things like a sale on at a store and things like that, I can't do that all locally. Battery will die. I'll have to have tons of storage. The data won't be fresh and everything else. But if I've got edge computing that's high performance and close enough that I don't notice the lag in it, then those processors can be ultra light, ultra efficient on that headset, say, for instance, but I can still have an incredibly rich graphical experience with all kinds of data and everything else, and it can follow me across the city. Those are the type of use cases that 5G will really, really enable and really push forward, and that's the stuff that gets exciting. But just like, say, the App Store of the past and everything else, you really need a very open, accessible, common ecosystem in order to be able to bring those applications to the customer. It can't be proprietary and onesie twosies here and there. It has to be something that works, somewhat at a global scale, and that there's not too many different avenues for developers to get into. So still some things to be worked out in that space, but you're right. 5G is not about doing what we do today from a mobile perspective better. It does do that, but that's not the thing that gets you excited. It's all these new use cases that come out that really, really drive it forward. And that's where it gets exciting. And that's where containers and public cloud and all of this stuff really comes together. And I would say, one of the things too that we missed just a little bit of is, I think it applies to the home network experience as well too, to be honest with you. Maybe not as many applications. I don't know how often I'm going to sit around with my augmented reality glasses in the living room, although who knows? If you asked me 20 years ago if we'd all be sitting on, staring at our phones in the living room when we have friends over, I would have said no, and yet here we are. So maybe we will. But it's really like, say, gaming is a very interesting example. I mean, latency matters in gaming. Gaming is huge. Esports is getting close to eclipsing regular sports in terms of revenue, if you can imagine that. And latency really, really matters in gaming. So if you could have your gaming servers sitting very close to your internet pipes, but in a way that any gaming provider can easily bring that in and out, maybe even in real time, as the demand comes up, as you know, a really cool game takes off in Edmonton, Alberta, Canada, they may swarm in their gaming servers automatically to drop the latency down and bring that capability up. So I see it beyond 5G as well too. Most people are talking about 5G, but I see application to home internet as well, to be honest with you, and just a ton of new use cases coming.
Now that you mentioned home connectivity, what's not, right? Should I ditch Wi-Fi when I get 5G?
Depends on the rate plan. To be honest with you, interestingly enough, if you actually look at the 5G from the radio perspective, the actual over-the-air, the way it sends data, they're actually very similar, to be honest with you. And one way to think of it would be that 5G is really just macro-scale Wi-Fi in terms of how it's deployed. But yeah, no, I mean, that's the other thing that we could use 5G for, especially when you get to really high frequency, very high capacity, doesn't go large distances, though. You could see a scenario where you have, very high bandwidth radios on every light standard, every light pole on your street. And then, again, to save efficiencies, rather than having to dig your front lawn up and run fiber into your basement, we say, you know what, you've got a multi-gig connection coming off the pole across the street. And if you think about it, I mean, who uses wired internet in your home anymore? I think I have one computer that's plugged in, and I think it's just because it's there and I've forgotten about it. I use everything Wi-Fi. So if 5G was faster and blasting across my living room, yeah, why not? And then I don't have to worry. I mean, how much do we spend fiddling around with placing those silly little Wi-Fi pucks and everything else and trying to optimize within our house? So yeah, you could see a scenario where, eventually mobile data does kind of substitute fixed data when we get more spectrum and more deployments out, and save us that challenge of that last mile physical deployment into your house, especially in areas that aren't served by fiber now. It's expensive, right? It's expensive to run that fiber in. It's expensive to run the fiber into the neighborhood and then hope people take it, because you have to serve the neighborhood even if customers aren't necessarily taking your service. So you take a bit of a risk in running through a neighborhood if you get enough adoption to pay for it. So yeah, I could totally see that scenario. We've talked about it for years. I think the technology just never quite was enough capacity for us to pull it off. But with all the different frequency bands and everything that 5G supports, those use cases are absolutely contemplated. Give it a few years, you might actually see that start to happen. We do a little bit of it in certain rural areas where we've got mobile data, and it's just prohibitively expensive to put in, physical networks. There is, fixed mobile internet access that comes into play for sure. So.
But now I'm getting confused a bit, and this goes back to the beginning of our conversation, right? Canada, as an example, and probably similar applies to US, is a huge country. You cannot cover it all and all the stuff, right? Now, I might have misunderstood, but the distance that a relay or whatever it's called, the 5G covers, is like fraction of what 4G covers, right? So
depends.
How do you cover the country then in 5G? If you need multiplied everything, right?
So 5G supports many different bands of frequencies, and so low frequency tends to go much further, and high frequency tends to. So low frequency is a lower throughput, lower bandwidth, but more distance covered. High frequency is much higher throughput, much higher bandwidth, but much lower distances covered. So there's a trade-off, but 5G supports both. So most of what's deployed in Canada today is very low frequency, high coverage area type of stuff. Actually, most of our 5G is in those bands today. But it supports all of those technologies. So no, you put them together and you kind of have like a umbrella that provides coverage, and then you have small high frequency things under that umbrella that provide your bandwidth. And you hand off between them. 4G networks work like this as well too, but with 5G, the amount of spectrum, the types of spectrum that are available to us are much, much different. And so we have much more options in that space. But yeah, no, 5G supports both long haul and very short, high capacity frequencies as well too. It's one of the things designed into it.
That makes so much sense, because kind of, and again, I'm not in this industry, I don't understand, but I saw a video a while ago, kind of a guy, lamppost, there is a receiver over there, 5G, he goes like 200 meters or whatever that is in feet or miles, kind of, and no more connection. And I thought, man, if they're going to put the receiver every I don't know, half a mile or something like that.
Oh, even worse. If it's the millimeter wave stuff, it's even shorter than half a mile. Unfortunately, it's very short distance. But yeah, so you complement that with an overarching lower frequency deployment that fills in the gaps, for lack of a better word, and then your phone hands off between all of those seamlessly, and sometimes can actually even access multiple of them at once to maintain its connectivity. So yeah, it's the whole radio world is its own engineering discipline with its own complexity as well too. That's quite fascinating on top of all of this.
But if the future is in, compute happening somewhere, and that somewhere being close to wherever the actor is, right? And we're talking about edge computing. Does that mean that at some moment we might be contemplating, I don't know, my fridge doing computing for a car around or something like that? Or
yeah, I think today not so much, just because the compute that we require is still a little heavy. It needs to have fairly good power, and you need a little bit more of it than you possibly put to someone's house. But yeah, you might get to that point. It's kind of analogous to when you hear Elon Musk and everything talk about Tesla and about cars plugged into your house actually participating in the grid because they have batteries and they can feed power in and out, and you can get this hyper distributed battery type of scenario. Yeah, you might arguably see that where when the connectivity gets good enough, my gaming PC could be providing edge computing for someone when I'm not in the house because I'm renting it out. I think we're a little bit off on that though, and security and reliability and everything else. That's it's a cool use case. Maybe towards the end of my career, as I'm retiring, maybe that's when I'll know. I'll see that happening and think that's it. I'm out. But once you get to this level of hyperconnectivity, I think your point is really bang on. You have lots of options. You have lots of flexibility, and it's really only limited by your imagination and your creativity at the end of the day and what you can do with it. And I think that's what's really cool about this technology. We haven't even talked about all the other industries. There's agriculture, there's healthcare. The list goes on and on and on and on and on. This is just going to be, this and artificial intelligence and all these things coming together. It's really going to propel us to the next level. You just get goosebumps being part of it. It's quite cool.
Yeah, I mean, that's kind of the whole that movement towards compute happening somewhere. And somewhere can be anywhere. To me, it's very fascinating, and I see it I see it in other types of industry. Like if you look at the development, right, less and less of the things are happening on your laptop. It's happening somewhere else. Soon we might have only a browser as all that a developer needs, theoretically, right?
Yeah.
Or in practice. And I know that this might not be directly related, but to me that's still very similar. Kind of. Everything interconnected and compute happening.
Just wherever
somewhere, right?
Just happening. Yeah, I think you hit it. It's so ubiquitous, pervasive, and well managed. It just happens, which is great, because then we can get on with solving the problems that we want to solve and not having to worry about managing the technology as much, which is kind of neat. You just leave it to, myself and a few of the other folks that just do the infrastructure engineering, and everyone else can go and be creative, and that's neat. That's awesome. I think that's where we're heading.
One last question, and then we close it. Are there any kind of open standards that you're working? Is there an equivalent of, I don't know, open API, open telemetry? The things that are happening in the more general area. Is something like that happening in telco as well?
There's two things in telco. One of them, you'll be able to tell by its name, has been around for a little bit. It's called 3GPP. And so it started in the 3G world, but it also wrote the 4G and the 5G standards. And so it defines all of the interfaces and all of the interconnectivity and the standards on how the phone itself connects to the network, how the airwaves work, how all the different machines talk to each other, how roaming works. All that stuff is laid out by 3GPP. And then, thinking of the infrastructure underneath it, the de facto standard has kind of been the Cloud Native Computing Foundation in terms of the software that provides that kind of cloud layer and how we're lining up to that. And those are the two big standards bodies, I would say, at the end of the day, that telecommunications companies globally are using to bring these new technologies to bear for our customers. So yeah, that's definitely... I think we need to rebrand the 3GPP, though. Maybe it's can call it the 5GPP.
I'm not even sure how to pronounce it. Is it 3G and then 2 Ps? 3GPP. Okay.
Yeah. I was hoping you weren't going to ask, because I'm trying to remember what they stand for. It's been so long. I think it was 3G Partnership Program, I think is what it stood for back in the day, but don't quote me on that.
I stopped asking that question because I don't know anymore, even for things that I work on, what they mean anymore, kind of like.
Yeah.
You just adopt the acronym and that's it.
It's a concept. It's the thing that makes the mobile networks go. It's the standards body. Call it what you like. Yeah.
I don't even know. What is G in 5 or 4?
Generation. So
generation. Okay.
1G was analog, 2G was digital, 3G brought mobile internet, 4G brought usable mobile internet fast enough, and 5G is bringing the cloud and edge computing. I would say that'd be the best way to think of it. And it's the 5th generation of mobile technology. So yeah.
Okay. Thank you so much. This was. I feel like if I don't stop now, we can go for a couple of more hours, and that's probably not
exactly. I'm sorry.
In our schedules.
It's a something you're passionate about.
Thank you so much for the conversation. I'm especially grateful because kind of usually I'm the one who knows something about the subject. It's telco. If you don't work there, you have no idea what's going on. So it's very interesting.
I hope I hope some of the listeners learn something as well too. This is a technology you interact with every day, and maybe you didn't know how it works. So hopefully you have a better appreciation for some of the challenges that engineers are breaking through to bring this to us at a global scale. It's fun, but it's not easy.
If it would be easy, we wouldn't have jobs.
Exactly. I'd be retired.
Exactly. Okay. Thank you so much.
Thank you. Very much appreciate it. Cheers.